Now let me go to the second, propositions. This will be, if you got confused a little bit in the previous section, this will be even worse. There are many things that are not quite natural to you. But the thing is, it is natural, only you think that's not natural. I can convince you that these are natural at today, maybe. All right, a proposition, the definition. The proposition in Korean is called 명제. You learned 명제. A proposition is a sentence that is either true or not, or false, let's say, but not both. It can be either just one of these, true or false. If you can determine this sentence is true or false, then, you don't have to determine this. If this sentence is true or false, then it is called as a proposition. 1 plus 1 plus 2. Is this a proposition? Is this a sentence, by the way? Maybe some people say, oh, it's not even a sentence, it's an equation, so it's not a proposition. Yeah, it is a sentence. It says 1 plus 1 equals 1 plus, it is a sentence. 1 plus 1 equals 2. Oh, 2. It is a sentence like this, only we wrote this in a simple way. So it is a sentence, and it is either true or false. It's true, actually, so it's a proposition which is true. 1 plus 2 equals 4. Is this a proposition? Yes, it's proposition which is false. X plus 3 greater than 2. Is this a proposition? No, this is not a proposition because it depends on x. If x is 1 or 0, it's true, but if x equals minus 3, it's not true, so it's not a proposition, it's not. But once x is fixed, it's explicitly given, it becomes a proposition. So this kind of thing is called a propositional function. Once you determine x is a proposition. But we will talk about this later. Okay, let me tell you more. Just number of students in this room is 62. Do you think this is a proposition? Yeah, right now. Yeah. So yeah. What about this? Earth is the only planet in the universe that contains life. Is this a proposition? Earth is the only planet in the universe that contains life. Yes? Okay, let's vote. Yes. All right. No, it's not a proposition. Not sure? If you're not sure, go back to this definition again. All right? And then think again. I understand why you think this is not a proposition. It's reasonable, but not mathematically reasonable. I understand why you think this is not a proposition, because no one knows whether this is true or false, right? No one can tell for sure that this is true or false. But it is either true or false, right? Here, did I write But we have to, somebody has to know that this is true or not, false. I didn't say that, right? If it's either true or false, doesn't matter. There is someone who can tell you that this is true or false. It's not in the definition. All right? So in doing mathematics, you have to really use the definitions only. Do not use your intuition or your opinion or anything like that. You may think, yeah, proposition should have, if you say this is true or false, there should be someone who really says that this is true or false. But that's not included. You may define that in your definition, but that's not a definition that widely accepted for math society. So this is the definition that we are going to use. So we need to follow this. So in this definition, this is truly a proposition. It's a proposition, not a problem at all. We just don't know this. So for instance, let me do this one more time. There are infinitely many twin primes. Twin primes means primes, two primes that their difference is 2, like this, or 17, 19, something like that. Is this a proposition? Yes. Is this true? No one knows whether this is true or not. It's still a conjecture. So no one knows that this is true or not. But still, it's a perfectly fine proposition. Okay? It's exactly the same as this in that sense. No one knows, but it's a proposition. All right? Do you think this definition okay? Do you think this definition is okay? Or do you want to include that somebody has to know, at least one should know this? You may want to include that in the definition, but it can be very tedious to check. Do we know, is this proved or not? You have to always check this. Okay? So I think this is a very good definition. Convenient definition for us. We can determine very easily, quickly. And something like this. It is warm today. Is this a proposition? Period. Maybe many of you will think this is true, but this is not something that we can explicitly determine, right? Some people can say, yeah, it's warm, but still there can be some people who say, no, it's still cold. So it's not a proposition. Any question?
Is it warm? It is warm for me today.
Okay, very good question. It is warm today for me. Do you think this is for him? Do you think this is a proposition? I would say no, because I don't know. Maybe it's really depending on maybe other people have different perspective, but at least I think differently. So I think it's not a proposition because you change your mind is not reliable. Your mind always changes. So yeah, this kind of thing is not. I don't think this is a proposition. Yeah. Because you don't know yourself very well. So yeah, we are not going to talk about this. This is not in the realm of mathematics. But it is, of course, important, but not mathematics. Okay, so we have propositions. And like sets, we can operate on propositions. We can define we can construct many propositions from another proposition. Propositions, these are propositions. And the conjunction of P and Q is denoted P wedge Q, like a wedge, is wedge. And this is by definition, it means P and Q. The name is not that important. I don't even remember this. But this notation you need to remember. It's like what's this? Intersection, but this it is angled, not round. And the disjunction of two proposition P and Q is denoted like this. This way, V, P or Q. And the negation of P, we only need one proposition for negation, is denoted neg. Yeah, it means not P. Okay, so these are definitions, but not 100% precise. We need to define this, or what does and mean? What does or mean? What does not mean? Yeah, you have, of course, some intuition, of course, but you have to be very, very precise, not to make any mistake, any possible mistake. So in order to define this more precisely, we need the following table called the truth table. So here is the definition. You can think of this as the definition. Or definition? This is what I mean by and or not. This is P and Q, P or Q. All right? So proposition, because these are propositions, they are either true or false. So let's write T if they are true, or TT, TF, FT. There are four possibilities, right? There are four possibilities like this. What about here? So in this case, we can fill out this table. T and T. So this means T and T. It is true. T and T, you can think of this as the definition of the word and. And is true if these two are true. This is also true. And this? False. True. False. True. False, false. And these are, in fact, the definition of and. You can think of this as the definition of and. The word and. This is the definition of the word or. So that means A or B is true if one of them is true. What if they are both true? This is still true. All right? So yeah, remember. Yeah, I think you have good intuition for this. This is fine. All right. Now P and negation of P. True or false? It's quite easy. Just if it's true, not P means false. If it's false, not P means true. Okay. So negate. Just change the value of truth value. This kind of thing, true or false, are called the truth value, and truth value are reversed for negation. This kind of table is called the truth table. It will be useful to prove something. All you need to do is to just draw a bunch of T and S. Any question? Oh, yeah? P가 false, not P equals true. Yes. Okay, so source prime. So question is prime. Every prime? Every prime is even. Let's say this is the our proposition P, and let's look at P and not P. Oh yeah, we don't need. Is this true? By the way, every prime is even? No, 2 is a prime. Oh, yeah, this is okay. Every prime is not even because 3 is a prime number which is not even, so it's going to be false. So not P must be true, but you think not P is also false. Not P, maybe you define not P in a different way. Not P here in words will be not every prime is even. Not P is not, every prime is odd. Right? They are different. This is not, maybe you're confused because you think you may have thought that every prime is odd. This is false, this is also false, but it's okay because it's not the negation of P. Negation of P is not every prime is even. Right? In other words, there is some prime number which is odd. Doesn't say that every prime is odd. So we will learn more of this later in details. Yeah, actually, it can be very confusing if you if you are dealing with every or some or all, and when you consider not there, then there is something strange or something something that changes. All can be changed to some or something like that. So you have to be careful when you are doing this. But we will learn this more in details later. Yeah, and here's another additional note. Operator precedence. This means there is some kind of order when you perform this operation. So we learned the 3 operations: negation, conjunction, disjunction. But we can combine them in one line. We have many propositions, and we can combine them using those operations, and then we can make a new, pretty complicated proposition. So when we do this, when these are mixed, we compute. There is some order. We compute negation first, and then AND operation, and finally this. For instance, this P and Q or Q and R. What this really means, this performed first. So you perform this first. And we have 2 things. Which one is performed first? This one goes first. So you compute this first. And then finally you compute this. In this way you can compute the whole thing. But there is some kind of order. But yeah, this is not an essential thing in proposition, so yeah, this is kind of confusing, so I'll try to write this way. You don't have to remember this. Yeah. But just remember that there is some kind of order. Yeah. I don't remember. I only remember this negation goes first. This is similar to similar to this. Negation corresponds to, in usual arithmetic, you can think of the negation as a minus. and this as plus, this as multiplication. So we have this kind of order precedence for arithmetic, right? So when we have like minus 3 plus 5 times 7, you consider this as a single thing. That means you consider this first, and you multiply this first, and then you add this. So it is some kind of similar thing like this. But yeah, I prefer to use parentheses because we are not as familiar, we are not very familiar with this as this. So I'm going to use just parentheses just to make sure that there is no possible mistake. Just remember there is something like the order precedence in these operations. Any question?